Okay, where are the others? Wala pa sila kasulod sa atin nga Zoom. So, can you, sinong nandito? Edgar, can you see my screen? Our next module. Presentation. It was here. Okay. So today we will be discussing uh, the second module or second topic for this subject. So we have the thermodynamics, the heat engines, uh, entropy, and the second law of thermodynamics. And okay, so for the introduction, so the first law of thermodynamics, which we studied, is a statement of conservation of energy. So this law states that a change in internal energy in a system can occur as a result of energy transfer by heat, by work, or by both. So only certain types of energy information or energy transformation and energy transfer process, no? So only certain type of energy conversion and energy transfer processes actually take place in nature, however. So the second law of thermodynamics, uh, which is the major topic in this module, so establishes which processes do not and do occurs. So we have here the following examples of processes that do not violate the first law of thermodynamics if they proceed in either direction, but are observed in reality to proceed in only one direction. So meaning hindi siya vice versa. No? So for example, we have here, when two objects at different temperatures are placed in thermal contact with each other, so the net transfer of energy by heat is always from the warmer object. Okay, so from warmer object siya to the colder object and never from the cooler to the warmer. Then next we have a second example, which is a rubber ball dropped to the ground. So it bounces several times and eventually comes to rest. But a ball lying on the ground never gathers internal energy. So from the ground and begins bouncing on its own. So wala siya ga kuha sa energy mismo. And we have another example, an oscillating pendulum. Ayan. So eventually comes to rest because of collisions with air molecules and friction at the point of suspension. So the mechanical energy of the system is converted into internal energy in the air, the pendulum, and the suspension. So the reverse conversion of energy never occurs. So all these, no, all these processes are reversible. So that is, they are processes that occur naturally in one direction only. So meaning there's no irreversible process has ever been observed to run backward. So if it were to do so, then it would violate the second law of thermodynamics. So that is the representation of. Next, we have the heat engine. So a heat engine. So a heat engine device that takes in energy by heat and operating in a cyclic process. So it expels a fraction of that energy by means of work. Syempre. So for instance, a typical process by which a power plant produces electricity, a fuel such as coal, so it is born, no? So pasabi nagsunog ka sang coal sa kay sang unang ano nga tiyempo, di ba? Ang aton nga engine is ano siya, a steam engine, di ba? So it is based on the steam of the coal. Mga trains natin before. So it is born, and the high temperature gases produced are used to convert liquid water to steam. So this steam is directed at the blades of a turbine, so setting it into rotation. So until now, no, ginagamit pa ni siya for generating electricity. Mga steam steam engine. So the mechanical energy associated with this rotation is used to drive an electric generator. Yan. So another device that can be molded or that can be modeled as a heat engine is the internal combustion engine in an automobile. Yan. Sa mga salakyan, ito. So this device uses energy from a burning fuel to perform work on pistons that results in the motion of the automobile. Yan. So let us consider the operation of a heat engine in more detail. So first, a heat engine carries some working substance through a cyclic process during which the working substance absorbs energy by heat from so the work is done and that's so the cycle repeat. So this okay. Ayan. As this one, heat engine. So as an example, so consider the operation of a steam engine or steam engine. So we have here, so kung matitingnan ninyo, the engine absorbs a quantity of energy. So that is Q sub H. Ayan. And then, so it came from the hot reservoir or dito sa hot reservoir at a certain temperature, no? And so for the mathematical discussion of heat engines, use absolute values. So to make all energy heat positive, so yun yung dinagdag mo. So walang bawas dito. And the direction of transfer indicated. Yan. Jack, kita mga-indicate sa ayan, arrow be equal to the negative engine that is being done. So the work here is negative because it is done on the engine. And then it gives up a quantity of energy that is Q sub C pababa. So papunta siya sa cold reservoir. Okay, so ito yung representation of a heat engine schematically. And because the working substance goes through a cycle, so pabalik-balik lang siya, then its initial and final internal energies are equal. So meaning yung change of internal energy mo is just zero. So from the first law of thermodynamics, di ba? So previous discussion natin, yung change of internal energy is just equal to the heat plus the work. Okay? And it is equal also to the heat minus the work being done, that is equal to 0. And the net work or the work being done by the engine or being done by a heat engine is equal to the net energy or the Q sub net natin, which is transferred to it. So as you can see from our representation or schematic natin, yung heat net natin or yung Q sub net natin is just equal to the absolute value of the okay, so ito yung difference nila, no? So that is Q sub H minus Q sub C. So therefore, we have a formula here. The heat, the work being done by engine is equal to the heat of, okay, so that is your Q sub H minus the Q sub C. Ayan. So the thermal efficiency, ayan, so ito yung formula natin. So take note na lang. So the thermal efficiency, that is italic na E, of a heat engine is defined as the ratio of the net work done by the engine during one cycle to the energy input at the higher temperature during the cycle. So that is E is equal to, that is the work done by the engine all over by the heat. Yan. So you can think of the efficiency as the ratio of what you gain, or that is your work, to what you give, or that is your energy transferred at the higher temperature. So in practice, all heat engines expel only a fraction of the input energy by, of course, mechanical work, and consequently, their efficiency is always less than 100%. So example siguro is a good automobile engine. So a good automobile engine has an efficiency of about 20%. And then yung diesel engines naman have efficiency of ranging from 35% to 40%. Yeah. So it shows that, or this equation shows that a heat engine has 100% efficiency. So it is only if yung Q sub C natin is equal to 0. Or that is if no energy is expelled to the cold reservoir. Okay, so in other words, a heat engine with perfect efficiency would have to expel all the input energy by work, because efficiency of real engines are well below 100%. So that is the that's the Kelvin Planck, no, from the second law of thermodynamics, which says, no, okay, so it says that it is impossible to construct a heat engine that operating in a cycle produces no effect other than the input of energy by heat from a reservoir and the performance of an equal amount of work. Okay, so this statement, no, yung statement na yon of the second law means that during the operation of a heat engine, so the work being done by the engine can never be equal to the heat. Okay, or alternatively, that some energy must be rejected to the environment. And so, for example, we have here a sample problem, no? Okay, so meaning hindi na siya pupunta dun sa cold reservoir, yung meaning nun. Okay, so we have here a sample. So that is an engine transfers 2 times 10 raised to 3 joules of energy from a hot reservoir during a cycle and transfers 1.5 times 10 raised to 3 joules as exhaust to a cold reservoir. So find the efficiency of the engine. Okay, so review natin yung review natin yung figure na yun, no? Yung figure na ito. Yan, review natin to. So think about the energy going into the engine. Okay, so from hot reservoir and splitting, so split natin with part coming out by work and part by heat into the cold reservoir. So meaning dalawa yung lalabasan niya. Okay, so sa example natin, sa sample problem natin, so it involves evaluation of the quantities from the equations introduced, no? In this section, so dito, so we categorize it as a substitution problem. Okay, so meron na tayong, ito yung equation natin na gagamitin. Okay, so we have we already have the given, no? May given tayo. And so that is 1 minus Q sub C over Q sub H. Yan. So yung Q sub C natin is, ito yung, sana yung problem natin. Yan. Ito. So yung Q sub C natin, ito yung 1.5 times 10 raised to 3. Ito yung exhaust, no? Papuntang cold reservoir. And then yung heat naman, yung Q sub H natin, that is 2 times 10 raised to 3 joules. So ito yung papuntang hot reservoir naman. Okay? Or that is 0.25 or that is 25%. Okay? So meaning the efficiency of the engine from this problem is 25%. Yan. Then the other problem or follow-up question would be how much work does this engine do in one cycle? So to find the work being done by the engine, subtract lang natin. That is heat minus the cold. Okay, so that is Q sub H minus Q sub C. Or that is 2 times 10 raised to 3 minus 1.5 times 10 raised to 3 joules. Or that is 5 times 10 raised to 2 joules. So ito yung work being done by the engine. Okay, so we just take the difference between the input, no, and the output energies. Yan. Okay. So question with regards to this problem. We can review that one later on. So another. Okay, so we have the heat pumps and refrigerators. Yan. So in a heat engine, the direction of energy transfer is from hot reservoir to the cold reservoir. Ito yung sa heat engine, which is the natural direction. Ito yung tama. Or ito yung parang process niya, or ito yung natural process niya. So the role of the heat engine is to process the energy from the hot reservoir so as to do useful work. So what if we wanted to transfer energy from cold reservoir to hot reservoir? So because that is not the natural direction of energy transfer, so we must put some energy into a device to be successful. And devices that perform these tasks is what we call the heat pumps and refrigerators. So for example, homes in summer, diba, sa atong balay. Yan. So, ano ito ginobra? So we could, ang ginagamitan, tapos siyang sa air conditioner, kita sing aircon. Okay? So homes in summer are cooled using heat pumps called air conditioners. And the air conditioner transfers energy from cool room. Okay, so from cool room in the home to warm outside. So di ba mapansin nyo na ang exposed no, ang likod ng air conditioner, nag-expose siya sa heat. Gilid sang ref, sa likod sang ref natin is mainit. Yan. So in a refrigerator or a heat pump, yan. Ito. Yan. So the engine takes in energy, that is Q sub C, from a cold reservoir. Okay, so pag from cold reservoir, that is Q sub C, and expels energy to a hot reservoir, so that is Q sub H natin. So which can be accomplished only if the work is done on the engine. Okay? So the work is done on the engine, hindi work is done by the engine. Kundi work is done on the engine. So the first law to the hot reservoir equal, the sum of the work done and the energy taken in from the cold reservoir, dapat maging equal sila. Based ating first law of thermodynamics, because first law of thermodynamics is conservation of energy. So therefore, the refrigerator or the heat pump transfers energy from a colder body. Okay. So colder body siya. So for example, the contents of a kitchen refrigerator or the winter air outside a building to a hotter body. So that is the air in the kitchen or in the room in the building. So in practice, it is desirable to carry out this process with a minimum work. So if the process could be accomplished without doing any work, so the refrigerator or heat pump would be perfect. But again, the existence of such a device would be in violation of the second law of thermodynamics, which is in the form of Clausius' statement, which states that it is impossible to construct a clinical machine whose sole effect is to transfer energy continuously by heat from one object to another object. And of course, at a higher temperature without the input of energy by work. So in simpler terms, so the energy does not transfer spontaneously by heat cold object to a hot object. So tingnan natin. Okay. Yan, so work input is required to run a refrigerator, of course. Okay, so meron tayong tinatawag na the effectiveness of a heat pump. Yan, so okay. So what is this? So it is described in terms of a number called the coefficient of performance. Yan, ito yung effectiveness of a heat pump. So meron tayong COP na tinatawag. So this is similar to the thermal efficiency for the heat engine in that it is a ratio of what you gain, or meaning that is the energy you transferred to or from a reservoir to what you give, or that is your work input. So for a heat pump operating in the cooling mode, or that is what you gain, is energy removed from the cold reservoir. So the most effective refrigerator or air conditioner is one that removes the greatest amount of energy from the cold reservoir in exchange for the least amount of work. So meron tayong, so ngayon nga meron ng mga inverter. Ito yung pinaka inverter type na refrigerator and inverter type na air conditioner, wherein mababa lang yung consume ng kuryente or mababa lang yung energy consumption niya. Yan. Pero may kamahalan nga lang sa parts, no? Pag nasira, so parang equivalent ay parang isang bagong refrigerator or isang equivalent niya ng piyesa na sira is parang bumili ka na rin ng bago. Yan. So take note of our formula here. That is cooling mode, so that's COP. Okay. So COP, or the coefficient of performance for cooling mode, we have the energy transferred at low temperature divided by work done on heat pump, or that is your Q sub C divided by W. For the heating mode naman, we have the energy H divided by the work done on heat pump. That is your Q sub over by W. Is Fahrenheit. So that is a negative 4% or higher. So the typical value of a COP for heat pump is about 4. If that is the amount of energy transferred to the building, is about 4 times greater than the work done by the motor in the heat pump. So syempre, using hindi pa air conditioner. So yung hindi pa refrigerator. Ayan. So for example, if you news, no? So refrigerator nila. So yun. Bakit? So yan. So yan. Refrigerator nyo. Yan. Ano pa? Kung sa aircon naman, dapat naka-sealed yung room para hindi makasingaw yung lamig. Diba? So this is mas refrigerator as well. Okay. So we have here some example problem. Let's take a look. So a certain refrigerator has a COP of 5. So ano ba to? Heat ba to? Or cooling ba to? Heating ba to or cool? So when the refrigerator is running, its power input is 500 watts. Okay, meron tayong power na given. And a sample of water of mass, let's say 500 grams, and may temperature siya na 20 degrees Celsius. So it is placed in the freezer compartment. So tanong dito is, how long does it take to freeze the water to ice to 0 degrees Celsius? Okay, so ilang oras ba bago maging ice o bago maging yellow yung tubig? So assume all other parts of the refrigerator stays at the same temperature and there is no leakage of energy from the exterior. So meaning wala tayong singaw. So the operations of the refrigerator results only in energy being extracted from the water. Okay, so how to conceptualize this one? So to conceptualize, so he leaves the water. So meaning into so in temperature and during your physics subjects. So the work being done divided by the change of time. Or in your change of time can be calculated now as the ratio of your work over your power. Okay? Tingnan natin. Ano ba dito? Wala. So, tingnan natin anong nangyari. So, we use the equation to relate the work, no? Or that is W being done on the heat pump to the energy. So, that is Q sub C. Okay? Ito yung papuntang cold. Okay? Or that is the energy extracted from the water. So that is your change time, change in time would that be equal to ano? Q sub C over the okay. And then okay. That is Q sub C. That must be extracted from the water of a mass. So we have that is
About the answer.
degrees. Okay, so that is your so 0.5 kilograms times ano yan? Times 4,186 joules per kilogram. Okay, so ano to? Ito yung ano C natin, or that is the constant, no? Boiling point of water. Check niyo na lang sa previous module natin. And you have your change in temperature, so that is 0 minus 20 degrees, or that is negative 20 degrees Celsius. Then subtract natin lahat sa 3.33 times 10 raised to 5. So ano tong 3.33 times 10 raised to 5? So ito yung okay, so saan to galing yung 3.33? Okay, ito yung mass. Okay, so ito yung mass ng ano natin, yung ng water natin. Okay? Then all over by, of course, your power that is given 500 watts, then multiplied by your COP, that is 5. Okay. So therefore, it can, or it will turn to ice by 83.3 seconds. Okay. So the time interval for the water to freeze in a refrigerator is much longer than 83.3 seconds, which suggests that the assumptions of our model are not valid. So meaning only a small part of the energy extracted from refrigerator interior in a given time interval comes from the water. That is, energy, yung energy natin must also be extracted from the container in which the water is placed. Of course, syempre naggamit ka sang imong suludlan sa imong tubig, so i-compute pa na siya. And then the energy that continuously leaks into the interior foam. Interior from the exterior must be extracted. So tanan nga components dapat i-consider naton. But based on this model, or based on our computations here, gina-assume lang nato, no, nga it is only the water refrigerator, yan lang. Okay, so that is based on our computations. But in reality, you must consider those factors. Yung gisudlan mo sa tubig, ang energy nga na-extract mo sa container, di ba? And then ang imo nga leak, syempre galik na ang ang aton nga energy from sa interior, no, from the exterior. Yan yung mga kailangan pang i-consider para makuha mo gid ang real time or reality time. Okay? Next, so we have the reversible and the irreversible process. Okay? Ito yung di ba? Second law of thermodynamics, yung irreversible, di ba? So in a reversible process, so ano to? So the system undergoing the process that can be returned to its initial condition. Tama ba? Is an equilibrium. So it's what we call irreversible. Okay. Okay, yun yung mga natural processes. Okay, so first, ito, figure natin. So this is the abiotic expansion of the gas. Okay. Tingnan natin. So consider a gas in a thermally insulated container. Okay, as shown in the figure. So a membrane, nakita niyo yung membrane yung sa gitna. Yan. So a membrane separates the gas from a vacuum. Okay. So when the membrane is punctured, okay, the gas expands freely into the vacuum, syempre. As a result of the puncture, the system has changed because it occupies a greater volume after the expansion. And because the gas does not exert a force through a displacement, okay, so wala tayong force dyan. So it does no work in the surroundings or it does no work in the surroundings as it expands. And then in addition, there's no energy. It is not to be surrounding volume. So, paano natin siya ma-reverse? System natin. Increase the gas. So, to be zero. Yan. So magiging zero yung transfer natin. Ay, na-late na pala. Tama. Ayan. So although all the real processes are reversible, some are reversible. Yan. Pwede naman so, sa ano sila? Nasa first law of thermodynamics sila. So the process can be approximated as being reversible. So how? So suppose a gas is compressed isothermally in a piston, say a cylinder. So arrangement in gas is in constant. Okay. Meron ba dyan? Example. Wala tayong example. Sige, natin to. Okay, so we have the next engine. Yan. So, viewpoint. So, mga mechanical engineers, no? He should give energy supply to higher temperature. So, efficient. Yeah. So, it, okay. Tingnan natin. Ayan. So the Carnot cycle consists of two adiabatic processes and two isothermal processes. All reversible. So pwede siya baliskad-baliskad, no? So tingnan natin yung process A. Meron ba dito? Wala. So tingnan natin yung process A. Okay. Medyo blurred lang siya. Medyo blurred yung ano. Okay, so sa process A, nandyan. So let's say from A to B. Yan. So ito yung letter A natin. Let's say we have a process A to B. So the picture is an isothermal expansion at temperature sa base. Okay, so nasa at is the base. So what happens? Expansion to okay, so the answer is okay. And ang mga babae. So dito. Dito. So and the gas energy sub BC. Okay. So during this time, on the gas, it, yeah, D. Yeah, so the gas here, D3, compression. Yeah, so the of the is compressed. Sub DA. Yeah. Okay. Tama. Reversible. Okay. So pwedeng pagbabalik na rin. So hindi naka-include yung example. Sige na lang. So let's proceed sa sa gasoline and diesel. Okay. Ayan. I think we have we have 10 minutes pa. Okay. So we will end by 5. So gasoline and diesel engines. Ayan. So in gasoline engine, so we have 6 processes. Okay, so 6. Unlike sa car not 4 lang. So dito sa gasoline and diesel engines 6. So ano na to? Ano yung mga to? So nakita niyo yung figure, that is active figure 22.11. Okay. So here we will consider the interior of the cylinder above the piston to be the system that is taken through repeated cycles in engine's operation. And so for a given cycle, yung piston, pataas siya. Okay? So the piston moves up and down twice. So pataas then pababa. That is twice, which represents a 4-stroke cycle. Okay? So meaning it consists of 2 upstrokes and 2 downstrokes. So 4 lahat. So the process in the cycle can be approximated by what we call the Otto cycle. Okay? That is OTTO cycle. Yan. So based on our diagram, tingnan natin to. Okay, so anong mangyayari dito sa first? Yan. Sa first natin, letter A, that is the intake, no? So during the intake stroke, okay, so anong nangyayari dito? So the piston moves downward. Yan, may arrow tayo dito. So it moves downward and anong nangyayari sa gas natin? So air and fuel, yan. And a gaseous mixture of air and fuel is drawn into the cylinder. So papasok siya sa cylinder. Okay? But of course with atmospheric pressure. So that is the energy input part of the cycle. So energy enters the system. So papasok siya sa loob, or that is the interior of the cylinder, by matter transfer as potential energy. Okay, so by means of a matter transfer as potential energy that is also stored in the fuel. So sa process na yun yung volume natin tumataas. Diba? So that is from V sub 2 to V sub 1. So this apparent backward numbering is based on the compression stroke, or that is your second process. That is sa letter B na. In which, yung air natin, yung natin, it already yung to your volume. Okay? And during the compression stroke naman, dito upward na. So what happens here? The volume. So okay, so that is so the work syempre of the area under the AB. So nadala. Sige. So dito ayan, sa letter D. So the picture in pushing the piston downwards. Okay. The area ED. So ito yung pabaliktad na. So how about sa fifth or sa letter E? So it is the release of the residual gases. Okay, so this occurs when an exhaust valve is opened. Okay, so meron tayong exhaust valve dyan. So the pressure suddenly drops for a short time interval. Okay. Kumbaga, ito na yung papunta sa tambutso ng salakyan. Yan. So, during the process. So yung residual. Yung okay. So bakit may binubugang aso yung tambutso? So ito 'yon. Okay. So diesel engine operates, no? So, cycle ba? Like auto cycle. Engine. And then you very high. Okay. So I think we have no time na, as much as I can, ano. So please study the remaining slides. We have 8 slides left, no? So try to study 8 slides left. And for your references, no, this is just a summary upload. But if you, the book, ebook, physics, click, uh, vision. Yan yung reference these slides. Okay, so I will leave to you the ano. I will stop sharing. I will leave to you the remaining topics for you to study. I will leave this one. Yeah. Oops. Yeah. Okay. So questions, clarifications. We will have quiz naman. We will have another quiz by next meeting. Okay. Sino yung hindi kakuha ng quiz? Present ba dito? O wala rin, absent. Check pa? Ano yun? Sinong wala kakuha quiz again, ha? Si Edan?
Ako, sir.
Edan? Wala. So I will give you a chance. Natin. So I will give you a chance. Ayan. So I will change the max attempts to 2. Then, ayan. So you have your 30 minutes. Okay, so try to submit again. Try to answer the quiz. You may start the quiz. Are you here in the Zoom? Wala. Saan yun? Okay, so sorry for the inconvenience sa sa audio, but I guess may recording naman tayo, no? I will just send the recorded session. I'll just message Edan. Change na natin ng ano. Ayan. Sige. Okay, so that's it, no? So if you have no questions, so medyo unstable yung internet sa school today. I'm not sure, maybe because of PLDT issue. Okay, so pag wala ng questions, clarifications, see you by next week. Meron tayong quiz again. Okay, and by the way, meron tayong CEW by next week, no? So I'm not sure if we can have a quiz. Let's try. Okay, so short quiz lang naman, like kagaina. So try to study the remaining topics and your or your experience number you posted, I guess, from your LMS, and your self-evaluation exercise. So even, no? Okay. Ayan. So thank you for the recorded. Okay. Bye-bye.